So this is lesson 4 on categorical propositions and classes. So just a recap. In our previous discussions, we have tackled the concept of arguments and logic, including premises and conclusions, which are standard structure for arguments. So basically, any argument contains one premise at least or more, and one conclusion or more. But the basic would be two premises and one conclusion. And we also have tackled two classes of arguments, which are deductive and inductive, emphasizing that in logic we use deductive arguments. Precisely because in inductive you have one conclusion first and then you verify this by observation and experience. Just like the hard sciences and social sciences, which are soft sciences, they try to have one conclusion and then verify it by observation and experience. How do they come up with one conclusion? Sometimes by small sample, by making generalizations. Not that they are wrong, but that they make a big claim and they verify this by experiencing and observation. So before delving into the fallacies, which are errors in reasoning, it is imperative to know first about categorical propositions and classes. Precisely because even if there is no informal fallacy involved, a deductive argument may be invalid rather than valid. Let me check if it's recording. So after this module, you are expected to at least be able to utilize and appropriately apply the knowledge, techniques, and tools necessary for philosophical and logical analysis, and you should be able to evaluate premises to determine the validity of arguments. So what we will be doing would be more on deductive arguments. So first, let's discuss the theory of deduction. So an analysis of the structure of arguments, meaning to say the premises and conclusion, is an integral part of logical investigation. It is to understand the relationship between the premises of an argument and its conclusion to determine its validity. So the deductive argument is one whose premises are claimed to provide conclusive grounds for the truth of its conclusion. So basically, the premises are given as support for the conclusion. So if the claim is correct, that is, if the premises of the argument really do assure the truth of its conclusion, with necessity that deductive argument is valid. In other words, it logically follows. So in every deductive argument, there is a claim. In every argument, even though it's inductive, there's a claim. So this claim is either correct or not, of course. It is verified either it's correct or not, which in turn makes it valid or invalid respectively. So the theory of deduction aims to provide techniques for discriminating between valid and invalid deductions. There are two kinds of this theory. First, we have the classical logic or Aristotelian logic, after the Greek philosopher Aristotle, who initiated the study of logic, and the modern logic or modern symbolic logic, which has been developed during the 19th and 20th centuries. So far, our focus would be more on the classical or Aristotelian logic. So, the Aristotelian logic or classical logic deals mainly with arguments based on the relations of classes of objects to one another. By a class, we mean a collection of all objects that have some specified characteristic in common. So, for example, the class of men. When you define what man is and you say that you are a man, you are included in the collection of the so-called men. Everyone can see immediately that two classes can be related in at least the following three ways. So first, all, using the word all, would indicate that all of one class may be included in all of another class. For example, the class of all dogs is wholly included or wholly contained in the class of all mammals rather. In other words, all dogs are mammals, and therefore all dogs are all mammals. The word some, but not all, emphasizing some part of the class, some of the members of one class may be included in another class. For example, the class of all athletes is partially included or partially contained in the class of all females. Thus, we may rephrase the idea into the following proposition: some athletes are females. In other words, in the second class of identifying whether the members of one class are included wholly or partially, would be to use these words all and some. And when you use the word some, you ask the question, for example, in this instance, all athletes is partially included in the class of all females would mean some athletes are females, precisely because not all athletes are females. That is evident, and that is really the case here. Next, we have two classes may have no members in common. For example, the class of all triangles and the class of all circles may be said to exclude one another. Having a particular size or shape rather would mean that it is no different. It's not the same. Rather, it's not the same with that of another form or another shape. Thus, we may rephrase the idea into the following proposition: no triangles are circles. So the above mentioned relations may be applied to classes or categories of every sort. In a deductive argument, we present propositions that state the relations between one category and some other category. Hence, it is called categorical propositions. So, categorical propositions are the fundamental elements, the building blocks of argument in the classical account of deductive logic. Let us consider the following argument. So, no athletes are vegetarians. For example, just for the sake of this argument, no athletes are vegetarians. All football players are athletes. Therefore, no football players are vegetarians. So there's a logical consistency and it follows. The argument contains three categorical propositions. We may dispute the truthfulness of its premise, but the relations of the classes, just like we discussed last time, expressed in these propositions yield an argument that is certainly valid because it logically follows. If and only if those premises are true, the conclusion must be true as well. So it is clear that each of the premises is indeed categorical. That is, each premise affirms or denies that some class S is included in some other class P in whole or in part. So in this illustrative argument, the three categorical propositions are about the class of all athletes, the class of all vegetarians, and the class of all football players. You have to be familiarized with this. So this is one type of categorical proposition, which means to say that there's no relation, or rather, these two classes, no, the class of athletes and the class of vegetarians, is exclude each other. The next one would be all football players, which are included in all the class of the football players, are athletes. The conclusion is the same as the form or categorical class of the first premise, meaning to say the class of football players exclude themselves from the class of vegetarians. So there are four and only four kinds of standard categorical propositions. So here are examples of each of the four kinds. All politicians are liars. All politicians are liars. Some politicians are liars. Some politicians are not liars. So let us examine each of these kind. We will be using Venn diagram here to illustrate the relation between these two uh, propositions, or terms rather. We have the subject and predicate terms. First, we have universal affirmative propositions using the word all. In such propositions, we assert that the whole of one class is included or contained in another class. So, for example, all politicians are liars. So, politicians, the class of all politicians, is contained in the class of liars. It asserts that every member of one class, the class of politicians, is a member of another class, the class of liars. So any universal affirmative proposition can be written schematically as where the letters S and P represent the subject and predicate terms respectively. So what is the subject term here? In this sentence, this is a simple sentence. It uses a linking verb. Usually in propositions, when it's not translated to using a linking verb, you should at least translate it in a way that will show the copula or the linking verb. So the subject terms here would be here, this one, our politicians, and the predicate terms would be our liars. So such a proposition affirms that the relation of class inclusion holds between the two classes and says that the inclusion is complete or universal. In other words, all members of S are said to be also members of P. Propositions in this standard form are called universal affirmative propositions, and they are also termed as A propositions. So categorical propositions are often represented with diagrams using two interlocking circles to stand for two classes involved. These are called Venn diagrams. But later on, when we do get to the argument structure, because in an argument we have at least three categorical propositions, we use three circles. So this Venn diagram is named after the English logician and mathematician John Venn, who invented them. So we will explore these diagrams more fully later, but for the sake of this identifying where the subject and predicate terms stand, we have to use this Venn diagram. So, so one circle is labeled S in this instance, which is the subject class, and the other circle, letter P, for predicate class. So the diagram for the A proposition, which asserts that all is S is P, shows that portion of S which is outside of P shaded out, indicating that there are no members of S that are not members of P. Or in other words, in this part of the S, this one side, which means that all S is included in the class of P. Or to put it in another way, since the relation between these two classes would be shown in the middle of the interlocking circles, as this part is not shaded, indicates that all S, all class of S is included in the class of P. So in knowing the relation between the class of S and class of P, or the subject terms and the predicate term, you have to look at their interlocking at the middle of the interlocking circles. When it is not shaded, it means that the class of S is contained in the class of P. Next, we have universal negative propositions. The second example above, no politicians are liars, no politicians are liars, is a proposition in which it is denied universally that any member of the class of politicians is a member of the class of liars. In other words, there's no politician that is a liar. So it asserts that the subject class S is fully excluded, from the predicate class P. So schematically, categorical propositions of this kind can be written as where, again, S and P represent the subject and predicate terms. This kind of proposition denies the relation of inclusion between the two terms and denies it universally. It denies it universally. In other words, all politicians are not liars. When you say no politicians, that would mean all politicians are not liars. So it tells that no members of S are members of P. So propositions in this standard form are called universal negative propositions, or also known as E proposition. So the universal affirmative a while ago, it is an A proposition, while the universal negative propositions is a letter E proposition. So the diagram of the E proposition will exhibit this mutual exclusion by having the overlapping portion of two circles shaded out. Again, like I mentioned a while ago, when looking at the relation between the subject term and the predicate term, and in using the Venn diagram, you have to look at the middle of the interlocking circles in order for you to determine whether the subject term is excluded or included or partially included in the subject of P, or rather in the class of P. So the E proposition is diagrammed as thus. It is shaded out to indicate the non-relational link between the class of S and the class of P. In other words, no politicians are liars. Next, we have particular affirmative propositions. Particular, in other words, partially, some part of the class, not all. And that's why we use the word some. So the third example above, some politicians are liars. Some politicians are liars. Affirms that some members of the class of all politicians are members of the class of all liars. Let's check if it's still recording. Okay. But it does not affirm this universally. In other words, not all politicians are liars. So it only affirms some members of the class of politicians. So only some particular politician or politicians are said to be liars. So the literal and exact interpretation of this proposition is the assertion that the class of politicians and the class of liars have some member or members in common. So that is what we understand this standard form proposition to mean. Some is an indefinite term that sometimes it can mean 2, 3, or 4. But in other words, it's just some members, no, just a part of the class, not all. You don't have to worry whether is it one politician, two politicians, three politicians. Just use the word some. Just like when making a claim, for example, in a certain class, you try to at least, no, refrain from making generalization, and hence you use the term some to indicate that not all of them are included in another class. So So context might affect our understanding of the term as it is used in everyday speech, but logicians, for the sake of definiteness, interpret some to mean at least one, or at least two, or more, but definitely not all. So a particular affirmative proposition may be written schematically as which says that at least one member of the class designated by the subject term S is also a member of the class designated by the predicate term P. So this proposition, particular affirmative proposition, is called an I proposition. So the diagram for the I proposition indicates that there is at least one member of S that is also a member of P by placing a small letter X in the region in which the two circles overlap. So in other words, this is how it looks like when you say some S is P. To indicate that not all members of S is a member of the class P. But to indicate that at least one of them, one of the class of S, is included in the class of P. And lastly, we have particular negative propositions. I hope you are getting the at least the flow or the pattern of how we define propositions. So first we have universal affirmative propositions. Then we have universal negative propositions. And the last two would be particular affirmative propositions and particular negative propositions. So the fourth example, some politicians are not liars, like the third, does not refer to politicians universally, hence it's particular, but only to some members of the class. So unlike the third example, however, it does not affirm the inclusion of some member of or members of the first class in the second class. So this is precisely what is denied, hence it is negative. It is written schematically as which says that at least one member of the class designated by the subject term S is excluded from the whole of the class designated by by the predicate term P. So the denial is not universal. So propositions in this standard form are called particular negative propositions. They are also called O propositions. So to indicate the word particular, we use again a small letter X. So the diagram for the O proposition indicates that there is at least one member of S that is not a member of P, but placing X in the region of S is outside of P, indicating that some of the class of S is excluded from the class of P. So the examples we use in this section employ classes that are simply named politicians, liars, vegetarians, athletes, and so on. But subject and predicate terms in standard form propositions can be more complicated. So for example, the proposition all candidates for the position are persons of honor and integrity has the phrase candidates for the position as its subject term and the phrase of persons of honor and integrity as its predicate term. The subject and predicate terms can be more intricate still, but in each of the four standard forms, a relation expressed between a subject class and a predicate class. So don't get too hung up when there is at least a phrase in a subject term or a predicate term. All you have to be mindful about is how you understand the sentence. And usually it uses the word all. If it does not use the word all, most of the time it is particular. No? It should be using the word some. Nonetheless, again, you have to at least understand the meaning of the sentence. Most often than not, when it is a universal, it uses the word all and the word no. And when it's particular, it uses the word many, some, a part of the group, and other words and terms that could be used to refer to some of the members of the certain class. So this four, A, which is a universal affirmative proposition, E, which is a universal negative proposition, I, which is a particular affirmative proposition, and O proposition, which is a particular negative proposition, are the building blocks of deductive arguments. So this is a simplified overview. You have to be at least familiarize yourself in how or rather how to indicate which categorical proposition is being given. So when the proposition does not use any indicator, whether it is universal or a particular, you have to first understand what is being said by the sentence. But again, most often than not, they use the word all, no, and the word some. So it is important to note the following characteristic of categorical propositions aside from knowing the categorical propositions. There are also characteristics of it. So we have quantity, we have quality, and distribution. So quantity would mean whether it is universal or particular. So the proposition A and E, which are universal affirmative proposition and universal negative proposition, has the quantity of universal. In other words, it indicates that all classes of the subject term is either included or excluded in the predicate term. So that's the quantity. And then we have, of course, the particular affirmative proposition and the particular negative proposition, which indicates that not all members of the subject class is included in the predicate class. Next, we have quality. This only refers to whether it is an affirmative proposition or a negative proposition. When it is an affirmative, it it indicates that indeed the yeah all of the class of subject term or some members of the class of the subject term is included in the predicate class, while negative would indicate that it is excluded from the predicate class. Apologies for this one. It keeps changing the volume. I'm trying to fix it, but to no avail. Anyway, and lastly, we have the distribution. Distribution would only mean um, whether the the terms all, some, or none of them in the class are included in the said class. For example, in this proposition, all S is P, the distribution will be only on S, on subject class. Why? Let's look at the first example we had. No? Um, all politicians are liars. Oh, these are liars. The distribution would be that it only pertains to the all members of this class of politicians. But definitely not all liars are politicians. Hence, the distribution is only on the subject class. One way to whether indicate or rather to know whether the distribution is on the subject term or in the predicate term, you have to ask the question. For example, in this the first proposition, in the A proposition, you have to ask, are all the liars politicians? If no, then the distribution would be on the subject term only. Or in other words, for the sake of uh, that you won't get dizzy when identifying the distribution, just keep in mind that in proposition A, this distribution is only on the subject class. On the proposition E, both the subject class and predicate class have the distribution. In other words, let's go back to the example. No politicians are liars would indicate that all members of the politicians are excluded in all members of the class of liars. So the distribution here actually, when you translate this one to understand whether the subject term is indeed has the distribution of the word all in of its classes, you have to at least translate it in such a way that would bring out, for example, in this case, no politicians are liars would mean uh, there are no there are no liars that are politicians. Again, para hindi kayo malito in Tagalog, para hindi kayo malito, just keep in mind that in A proposition, the distribution is only on the subject class. In E proposition, the distribution is both on the subject term and the predicate term. Um, on both on I proposition, neither is distributed. In other words, some S would mean some members of the class of S, and some SSP would mean that some members of the class of P is only mentioned, no? Not all. Again, you have to translate. For example, let's go back again to the given praised. Some politicians are liars would mean not all liars are politicians. Again, para hindi kayo malito, you have to know, at least, no, in this part, you have to identify first what kind of proposition it is. Then, only then, you can know the distribution. And lastly, the distribution in the particular negative proposition would be on the subject class only. Usually, when it is a negative one, uh, negative term, for example, the indication would be that all members of that class are not. Now, things are getting more complicated in this part, okay? But in this instance, you have to at least familiarize, for at least for this time. You have to at least familiarize. So we have the square root of opposition. So there are four ways in which propositions may be opposed as contradictories, contraries, subcontraries, and as sub and superall terms. So these are represented using an important and widely used diagram called the square of opposition. This one. What does this mean? It means that first, when there's a contradictory, they um, one is only true among them. For example, when you say all S is P, then definitely, for example, let's go back to the given proposition. All politicians are liars. When you have that claim and it is true, then the contradictory would be uh, some politicians are not liars, and that would not make sense if the first proposition is true. Or that when you say some politicians are liars, when you say that is true, then it's contradictory, which is all politicians are liars, would mean indicate that it's false. Precisely because you're already uh, identifying that all members of the class of S is included in the subject, in the predicate class, while in its opposite, which is the proposition O, mm, would indicate that only some members, part of the group of the class of sub the subject term, is excluded from the predicate class. Again, you have to familiarize yourself with this one. You may pause this video for you to be familiarized with this one. So relations exhibited by this square of opposition were believed to provide a logical basis for validating certain elementary forms of argument. To explain this, we must first distinguish between immediate inferences and immediate inferences. Inferences. So when we draw a conclusion from one or more premises, some inferences must be involved. So that inference is said to be immediate when more than one premise is relied on, as is the case with syllogisms, where the conclusion is drawn from the first premise through the mediation of the second. However, when a conclusion is drawn from only one premise, there is no such mediation, and the inference is said to be immediate. At least to clarify, no? But I think and is more on the sense of whether to indicate the how the inference was made. So a number of very useful immediate inferences may be readily drawn from the information embedded in the traditional square proposition. So for example, if an A proposition is the premise, then one can invalidly infer that the corresponding O proposition is false. The one I'm trying to explain a while ago. If an A proposition is the premise, then the corresponding I proposition is true, that some S are P. If an A proposition is the premise, its corresponding E proposition which contradicts it must be false. When you say some S are P, definitely you would not say that no S is P. So given the truth or the falsehood of any one of the four standard form categorical propositions, but the truth or falsehood of some or all of the others can be inferred immediately. So a considerable number of immediate inferences are based on the traditional square of opposition. To at least to make it easier for you, these are the guide. These are the guide. So when A is given as true, E definitely is false. I is true, some S are P, and definitely O is false. When E is given as true, in other words, no S is P, A is false, I is false, and O is true. What is an E proposition? No S are P. So definitely you would not say that all S are P and some S are P. But to say some S are not P would still make sense. When proposition I is given as true, proposition E is false, and proposition A and O are undetermined. Why undetermined? Because it's not clear whether they are either true or false. When we say some S are P, does not also mean that all S are P. Not that it falsifies, but rather that it's undetermined. And when you say some S are P, definitely you will not be sure whether some S are not P. Because again, like we said a while ago, the word some would can indicate that at least one member of the class is included or excluded. The O proposition, if the O proposition is given as true, proposition A is false, and the propositions E and I are undetermined. Now let's go to the false. Whether if each of them is false. If an A proposition is false, then the proposition O is true, and propositions E and I are undetermined. If the proposition E is given as false, proposition I is true, propositions A and O are undetermined. If the proposition I is given as false, proposition A is false, and both proposition E and O are true. Lastly, when the proposition O is given as false, proposition A is true, proposition E is false, and proposition I is true. So a proposition is undetermined if its truth or falsity is not determined, or rather fixed by truth or the falsity of any other proposition. Para hindi kayo malito, again, you have to familiarize yourself with this one. So first, you have to memorize at least. No? At least in this part, you have to memorize what does an A proposition entail, what's the format of A proposition, what's an E proposition, what's an I proposition, and what's an O proposition. Okay? The point of making this recorded lecture would be for you to identify or be familiarized. You have the liberty to pause at any given moment at your own pace. Because when you're getting busy, or at least when you're not being able to follow this part, you can always pause or go back rather to the point or the explanation. Right? Okay, I will stop there. Again, you have to familiarize yourself first with what kind of proposition is given. There are only four kinds, and after which you have to identify whether uh, what the quantity is, what the quality is, and the distribution. You also have to familiarize yourself with the square of opposition. And lastly, with this square of opposition, the simplification will be this one. Whichever for you is easier to understand, or at least to be familiarized at. Whichever is for you, whichever for you is easier to be familiarized. Either this one, some of you might see this as the easier one to get familiarized at this square of opposition, or you go here, this part, whichever is easier for you to get familiarized. Okay? I will be uploading the activity for this one later. For now, all you have to do is listen to this recorded lecture. And thank you for listening.